Welcome. In today's session, I'd like to explain to you how to handle errors in PowerShell. There's nothing worse than writing code and having error messages thrown at you. Therefore, I'd like to show you a couple of easy ways to deal with errors while you're troubleshooting your PowerShell code. Okay, first of all, we can distinguish between two error messages. The first are terminating errors. These are serious or fatal errors during execution. These errors will stop processing your code and they will exit your PowerShell script. The second are non-terminating errors. These are non-serious errors. These include operational errors such as file not found, permission problems, or any kind of other runtime errors. These will throw an exception that is normally displayed in a red color. Okay, when an error occurs, it's written to a global object variable called the $error variable. To view how many errors have occurred, you can call the count property, and we do that by specifying the $error and then the .count property. This will just show you how many errors have occurred. When we look more deeply into the object, we can see that the error variable is actually an error list, or sorry, an array list. We can do that by calling the $error get type method. These error messages are indexed in reverse order, meaning that the first or the latest message will always be indexed to 0, and all the older messages will be moved one index up. So the message that occurred before that will be moved to 1, and an error message that even occurred before that message will be moved to index number 2. If we want to see what kind of or which exception was thrown, we can call the index. So we specify the error with the square brackets index 0, and then the message or the exception. This depends on what sort of type or what sort of type of error occurred, and this way we can see what the message or the exception was. Error action preferences are preferences that can be set for the entire script, meaning that if an error occurs, it will use whichever preference you've set in the beginning of the script. Actions that you can use are the stop preferences. This one will force the execution to stop. It would react the same way as a fatal error would occur and would just terminate your PowerShell script. Another one you can use is silently continue. The error message is just suspended and the execution will continue. The continue is the default setting. The error will display and execution will continue. Inquire will prompt the user for input. You can specify yes to acknowledge the message. You can specify yes to all. That will prevent pop-ups from coming up anymore. You can specify halt. This will stop the processing. And another one you can specify is suspend. That will just silently continue. If you specify ignore, the error messages are not logged and are not written to the error variable. This is an example on how to specify the error action preference. The default is continue, like previously mentioned. This will mean that the error is thrown, but the processing will continue. Another one is stop. This will completely terminate your script and exit the code. You can specify silently continue. This will not throw an error message, but the error messages are still logged to the error variable. If you don't want to specify the error action preference in the beginning of your script, or you want a different result or the commandlet to react a bit differently, you can specify that directly in the commandlet by using the error action preference as specified up here. PowerShell's also got a lot of little shortcuts that you can use. So instead of writing out error action, you can call the alias EA that has got exactly, or that actually does exactly the same as calling the error action preference. Okay, the try, catch, and finally block sequences. They actually do exactly what they say. You need to specify at least the try and the catch. The finally is optional. In the try block, you can specify a commandlet that will execute. As soon as it throws an error, the catch block would start executing, and this is where you can start handling your error messages. In the finally block, you should use that to clear up any variables or any objects that you've stored in memory, just to make sure that they are clean and that you don't use too much memory. The write host you can use in the try and catch sequence, for example, to write information to the console. I would recommend that you use a different color. To do that, you would call the foreground color parameter and change it to something like yellow. This just makes it easier if you're troubleshooting, because then you can actually see that you are handling the error. If it displays it red, it's something that you haven't dealt with just yet. Another useful commandlet is the Send-MailMessage commandlet. You can use this to notify yourself or your team about error messages that have occurred in your code. Of course, you can also use it to send out an email that specifying that your script has run successfully. To use the Send-MailMessage commandlet, you need to specify the following. The first is the to email address where you want to send the message to. You need to specify a from email address. You need to specify a subject. You need to specify a body. I would highly recommend that you use an HTML body. This just makes it nicer because you can format the text and you can use different colors and bold text to highlight features or messages that are of interest. Another thing you need to specify is the SMTP server. And depending if your SMTP server needs credentials, or authentication, you need to specify a username and a password to authenticate to the email server. Okay, so if we look at the commandlet, we should store these parameters in variables, and because these might change throughout the script. As you can see, we have the to parameter, the from parameter, the subject parameter. We're specifying a body as HTML. We are also specifying the SMTP server. And like I said, optionally, you need to, or depending on if your SMTP server you have to authenticate to it, you need to specify the credentials as well. Another useful way to troubleshoot your code is to write messages to the event log. To be able to do that, we first need to specify a name. So we're going to write this to a variable. Then we can create a new event log by using the New-EventLog commandlet. We need to specify the log name and the source parameters. Application, security, setup, system, forwarding events are default values that have been specified by Microsoft. If you want to specify your own log name, you can do that by just writing a different name. This could also separate your events from the default application events that are written to the system. So in this example, we are creating a new source called new test event and writing it into the application log structure. This only needs to be done once, and this should not be part of your script. This is something you should run once on the server just to create the application log, and then you can start writing into that. To write into the message, we're first going to create a variable of the message that we want to write into. We can write anything into the event log. In this example, I'm just getting the date when the process is started, and then I can write that into the message or the event log. To write stuff into the event log, you call the Write-EventLog commandlet. The parameters that we need to specify are the log name. So since we previously used the log name applications, you should use the same one. Same as the source. The source has already been created. Another parameter you need to specify is the entry type. This can be information, warning, or error. You need to specify an event ID. And of course, you need to specify the message that you want to write into the event log. Okay, I would like to demo all of this in PowerShell. Okay, I've opened Windows PowerShell ISE to demonstrate to you how to handle error messages in PowerShell. The first thing I'm going to do is I'm going to call the commandlet that does not exist. So if I execute this, I will right away get an error thrown at me. And as you can see, it's an object not found. Each error message is stored in the $error variable. So if we call the $error variable, you will notice that we get exactly the same information as we got with the error when we executed the wrong command. Now, if we look at the properties, we can do that by specifying the error and a dot. We get all the different properties and all the different methods that are available. The one I'd like to demonstrate is the count. So we're going to execute that, and you will notice that only one error message has currently been written into the $error variable. To see what sort of type it is, or data type, we are going to execute the getType method and also specifying the .name. There we only get the name. So we execute this. You will notice that it's an array list that the information is stored in. And arrays work with indexes, and indexes always start at 0 and go up to 1, 2, 3, 4, 5, and so on. So if we only want to get the error message from the last index, we do that by specifying the 0. And these error messages are indexed in reverse order, so they start at 0 and go up to 1, 2, 3, 4, 5. So if we execute that, we can actually get the exception that was thrown, and this is very useful if you want to add this to your script, that you get a response of what actually happened. Now we can also run the data type to see what sort of variable execution type it is, and you can see this is a command not found exception. Now next I'm going to throw a parameter binding exception. If I execute this, you will notice that's an invalid argument. Just to show you that we now have two messages written to the variable. So if we call the latest one, like I said, it's always 0 is always the latest message. We can call the type to see what sort of name it is, and it is a parameter binding exception. Okay, next I'm going to throw a runtime error. This is just something that does not exist. It's an invalid method. So if we look at the count again, we notice it's written 3 error messages into the variable, and if we execute the exception getType, we can see that it is a runtime exception. Now, to have a look at all the different indexes, we can do that by calling them individually. So first of all, I'm going to call the latest one. Then I can call the one that we have previously done, executed, and this is the first message that we've actually gotten. So there was the commandlet that did not execute. To view all of the variables that have been written, you don't specify an index. So what I'm going to do is I'm just going to clear the screen, and then we execute the error messages, and if I scroll up, you will notice that all 3 exceptions have been written into the variable. Okay, this is just another parameter binding. I'm not going to execute that because we've already done that. Now, the next is the error preference. So if I call the ErrorActionPreference variable, you will notice that it's set to continue. Continue is just the default setting. If we set it to stop, this will have the effect that our script is going to terminate, and this would do exactly the same as if a fatal error would occur. If we set it to silently continue, I'm just going to set it to silently continue, then we can just have another look at how many error messages we have. Currently we have 3. I'm going to call another error message, and if we look at it again, so we've set it to silently continue, that's why it does not throw out an error message. But if we call the count again, we can notice that we actually have 4 error messages that have been written into the variable. Therefore, I'm just going to call the last index again, and you can see the error message thrown was an attempt to divide by 0. Now, another thing you can do is, instead of specifying the error action preference in the beginning of your script, you can also set it individually for each commandlet that you would like to run. So if we specify the getChild and we specify the error message to inquire, this will actually pop up a window and prompting us to what we want to do. We can either specify yes, this is just going to continue. We can specify yes to all. We can halt, this will execute the command, or we can suspend, this would just silently continue. Now, if we do exactly the same, instead of calling the error action, we can just use the alias. This is just an E and an A. And if we do that, we get exactly the same as if we would run the error action. Now, what we're going to do now is we are going to throw another exception. I'm just going to set it back that we actually do get the error messages. So I'm going to set this to continue. Continue. All right. Now, the next is the try, catch, and finally blocks that we can use. In the try, you specify what you want to run if you want to test something. If an error gets caught, it will continue by using the catch phrase, catch block. And after you're done, you should always clean up whatever you've done by doing that in the finally. So if we execute this command, you will notice that it first of all runs the error, the new object. It catches an error. In the error block, it says that it's caught an error, and that's what the answer. That's what we're actually getting down here. And after the catch block is finished, it goes to the finally stage, and the finally stage you should always use to clean up whatever you have set up or whatever variables you have. Another very useful command is the write host. So what we are going to do is we're going to just run these together that you can see what the differences are. Is to write the error messages out either in yellow or whatever is your favorite color, just that you can see that these are error messages that you're dealing with. And if they are red, that's something that you haven't dealt with. Good. To specify or to use the Send-MailMessage, what we first of all need to do is we need to specify the to command, we need to specify the from command, we need to specify the subject, then we use the body as an HTML. You should also include the error message just to notify yourself. If you don't know what sort of error is thrown, it's an easy way just to use the default settings and just let the error variable specify what sort of error it has occurred. And then of course you need to specify the mail message and any credentials that have been set. So if we would run that, you would specify all the error or specify all the variables, and then you call the send-mail commandlet and add the variables to that. Obviously, this is not going to work because I don't own the domain mydomain.com. Okay, to write information to the event log, we first of all need to specify the name. We're going to write that into a variable. Secondly, we specify the new event log. You need to specify the log name. You're going to write it into your application. And you need to specify the source. And we're going to use our variable. Okay, this creates a new event log onto your system. You only need to do this once, so make sure this is not part of your script. Then to write into the event log, you should create whatever message you would like to write into something, into a variable, and then if you want to write that, you go Write-EventLog. You need to specify the log name again, application. Then we need to specify our source. We're just going to use the variable again. Then you need to specify the event ID, the entry type. That will be either error, a fault, information, or warning. We're going to specify warning. Then you need to specify the event ID. Specify that as number 1. And of course, last, we specify the message. And the easiest way is just to call your variable log message. And this will write information into the event log. Well, this concludes our session. I hope you've enjoyed the session, and I'm looking forward to our next one.